Hey everyone, Tom here from TechNexus, and thanks for joining me in today's video. Now, the last few days or so, I did a little bit of Plant 3D training online, and there were questions about catalogs and specs. And I just want to make it clear that doing catalogs and specs can be quick, but it can also be time-consuming, and there's too many variables in trying to lock down how long it might take. If you're a Plant 3D administrator or even a manager on an upcoming project for Plant 3D, then this could be a good video to watch, as I'll go through what it takes to do a catalog and then ultimately a spec. Now, the basis of a electronic spec, so this one here that's CS150, part of the software. The basis of these specs are what's called a paper spec. Now, a paper spec comes from the client or a process engineer or somebody on the project who knows what the process needs to be carried in. So if it's a gas, whether it's oil, whether it's water, whether it's pharma, food, whatever, that will ultimately dictate what flanges, bolts, gaskets, elbows, valves, everything that you use. Now, these paper specs, like anything on any job or any project, or regardless of whatever you're doing, if it's not done right the first time, it will take time to build a catalog and ultimately a spec for these items. The more information in the spec, the easier it is for the Plant 3D administrator to create these specs and filters. Okay, so a spec in Plant 3D is a filter of elements in a catalog. Now, Plant 3D does come with a few different catalogs. So if I look at my 2021 AMI, ASME, AWA, and DIN, you can download more from Autodesk. They might be free from Autodesk, or they might be paid for catalogs from other resellers or people on the App Store. Now, if you don't have elements in a catalog, you have to make them. And not every element is always going to be there. I figure at some point Autodesk helps you create elements, but they're not going to do everything because they don't know what every kind of project, every type of fitting there is out there. It's too big a job to do it. Okay, so if I look at the ASME pipe and fitting catalog, if I sort by the short description, you can see I've got a whole bunch of bleed ring bolt sets. Scroll down, so caps, couplings, reducers, basically everything. And I like to sort of assimilate it to being in Bunnings or a hardware store or something where there's a whole bunch of fittings available for you to use. Okay, if you're going to be building them from scratch, and might be some component that it isn't in the ASME catalogs, it's not in the Australian catalogs, it's not in any other catalog, you have to make it. You click on this button called Create New Component. So what you do here is you look under the category. So let's say flanges, and we look at the flange component. We nominate that it's a flanged primary end type, and then we can go through and pick what kind of flange it is. If it's not in any of these categories or components, you can make an AutoCAD based object. Now, if you're already following my channel or subscribe to it on YouTube, I did some videos a while ago on building items in Fusion 360 and then exporting to AutoCAD and then doing a plant part convert and then ultimately bringing them into a catalog. The issue for these AutoCAD objects is you have to build one for every size. Okay. There might be ways to do it in Python. I don't know enough on Python, so I'm not even going to make a comment on that. But if you're going to make AutoCAD block-based, you have to do every size. So if you're doing a valve from 15 to 250 mil in nominal diameters, then you have to model every single one of them. You can download them from the vendor website, but you have to make them into a plant catalog. And as far as I know, none of the vendors that I've seen even recently build the catalogs themselves. They just issue the parts as DXFs or STLs, SATs or DWGs online, and then you have to do it. The third way to do it is the catalog builder. Now the catalog builder is part of this catalog editor, and it uses Excel to build the catalog. So if you're really good at data entry in Excel, then you can use that. Okay, so if you are making paper specs and you're doing objects that are rare or hard to get or expensive and they haven't been modeled, then when the Plant 3D administrator tells you it'll take time to build it, it will take time. It's not that they're trying to extend the project or get paid more or whatever else. It does take time. This is why I say to people the first couple projects will always take the hit in regards to time and money for building these catalogs. Afterwards, that graph or sort of slows down and drops down to almost basically zero. Okay. I usually quote, to build any spec, I quote 3 days or 24 hours of work time, okay? And that takes into account me building it, printing it, sending it to the engineer, them checking it, me backdrafting it, and then reissuing it 2 or 3 times possibly. It's never, in one hit. People always have a comment or an opinion to add, and that's why it takes time. But once it's done for that project or that client or that process, material, rating, whatever, it's done for life in Plant 3D. The other thing that also takes time is the branch table. So the out-of-the-box CS150 spec branch table is here. I usually recommend to people to have a look at this as a guide because it's laid out well. It gives people an idea that, we can... on a 12-inch header, we can have a 1.5-inch branch, and the 2 options are stubbins or socklets. Okay, and if we look at something bigger like 4-inch to 3-inch, we can do a reduced T, a T and a reducer, or a stubbin for the 3 different options. This table has to be done in the paper spec. Okay, don't leave it up to the plant administrator to do it. They're not qualified to do it. There's so many variables in here. Again, material, rating, pressures, temperatures, all that sort of information needs to be worked out by someone who has the authority to dictate what these branch tables will be. The branch table tells the software what to do at a 6-inch header to a 6-inch branch and what the end user can put in and what they're allowed to put in. Okay, the idea of a spec is it limits the designer to only put into the project what they're allowed to put in for that process, for that client, for that temperature, the pressure, the rating, all of that kind of stuff. Okay, so again, a catalog, if there's anything in the ASME catalogs, it's pretty much just easy, just drag and drop into the spec and you can use it. If you need to add parts, it takes time. So you have to be understanding that these specs don't just happen overnight. Things like long descriptions, things like sizes, things like part use priority, all of these things need to be defined because it's just part of the software and how to do it. If you want to use the out-of-the-box specs, then feel free to do so, but there's size issues here, there's rating issues. They might not be for oil and gas or for water or for whatever project you're doing. Okay, so I usually say if you're doing an early stage of the project and you don't have time or don't know what the specs are, then feel free to use it. But put something on the ISOs to say that it's not to be used for purchasing or for actual detailed design. These could only be used for early stage. You need to check them. You need to confirm that everyone is okay with the ratings and the facings and all of that kind of stuff, because ultimately that flows down to the fabrication drawings, and you don't want someone welding up a 150-pound flange on a line that needs to be rated for 300-pound flanges. Okay, so to just go over quickly what I've spoken about. If you need to build something in a catalog, it takes time. It's going to take time on the first 1, 2, maybe 3 projects, but after that, it's basically done and dusted. Specs take time. I allow 3 days or 24 hours of work time from me drafting it to issuing it into the software. Sometimes that might only take 2 hours. It might take a bit longer. Whatever, there's too many variables in there for me to lock down what it could take. Okay. Also as well, if you've done one particular spec in CS150 or it's carbon steel or whatever, and you just need to update sizes, then as a plant administrator, tell the manager, tell someone that it'll only take an hour or two of time. It won't have to take the 3 days. Okay, not every spec is going to take 3 days. The very, very first one of that, allow a couple days at least. I say 3 personally myself, just to allow for time, but it tells people on the project that they need to allow time for that before the piping can actually start on the project. Okay. And then lastly, the branch table inside the spec, it has to be completed. There has to be something in there because, again, at the end of the day, the software needs to know what is going to happen at each of these branch and header connections. Okay, so if you have any questions or comments, please do make them in the comments list below. If you're doing it on YouTube, feel free to do it on YouTube. If you're seeing this on LinkedIn, add it on LinkedIn. I'm more than happy to make comment. I'm more than happy to do an online session with yourself personally to go over this with yourself, with managers, with whoever, because these things do take time. Okay, so closing up, thanks for watching. Hope it was informative. It answered a few questions for you. Thumbs up if you liked the video, thumbs down if you didn't. But as always, please do subscribe to my channel, and I will see you next week for some more maybe plant content. See you later.